Hey everybody, Monte here, and we're in Honors Pre-Calculus, and we're preparing for calculus for next year. Okay, we've finished what we had to do out of Honors Pre-Calculus, and literally all pre-calculus, Honors Pre-Calculus classes spend the last month of the year preparing their students for calculus, because it's a next level. Okay, we're taking everything we've ever learned and we're building on it so that we can study instantaneous, continuous, and start to evolve into full-blown engineering. All right, week 34, May 24th to the 28th. And we've been looking at some videos on limits and motion. Limits and motion. Okay, so pre-calc, we got a Teams page here, we post our videos here, we got a stream channel here. Most students just go to the internet, digital tools, Clever, Blackboard, click on our Honors Pre-Calculus class, and you will see the cheat sheets, we'll see all the videos posted, week after week after week, so you can always go back and refer to them if you need to. All right, and I want you folks to be self-paced. We're going to be in Unit 9, and the key here is note-taking. Okay, these concepts, this vocabulary, this idea of instantaneous, a point in time versus average time, and that's what we've been working on. So grab yourself some sort of spiral, make sure that you are watching each of the videos, okay? And if you remember last time, we've only got what, 4 videos there, 2 videos there, and we're not even going to look at these 3 videos until we get to June. Okay, so for next week, Mathxl, and we'll go down to pre-calc, and last week we looked at the tangent line, a curve in this tangent line, a point in time, instantaneous velocity as compared to average rate of change. Okay, so let's see, what did we do there? Yeah, we did 3 of them. Let's just click on question 8 for this week. And the slope of the line. Remember last week on the video, I wasn't sure what to do. We take that instantaneous and plug the value -1 into it. Okay, so let's just view an example here. We have 5x squared at x equals 1, the slope and the derivative. Okay, this idea of a derivative. Okay, so the limit of this function plus h minus the function, provide the limit exists. Okay, so now we plug these in. Okay, a plus h minus f of 1, which is 5, right, as h approaches 0. Okay, so now we've got this 1, so 5 of h as the limit. Evaluate the limit as it approaches okay, let's do this one together right there. Okay, let's put this here and put this here. Okay, so we're going to want to watch a couple of those videos, okay, about the idea of a derivative. All right, and what we're talking about is a given curve. Okay, a given curve. So in this particular case, 5x squared, 5x squared, x squared, 5, so it's going to grow fast, right? Grow fast. Now I'm going to expand this out just a little bit. I know this kind of is distorted. But we want to study at x equals 1. So we're going to call this 1. Okay? How does the curve change as we approach from both directions? Well, if h is 100, way out there, right? We're way out here and we're way out here. That is not a very good indication of what's right here. But as h gets smaller, as h gets smaller and smaller and smaller, closer and closer and closer, we get more accurate until we're right on it. Okay, so that's this idea of h. So now let's write this out. Y equals 5x squared. Okay, now we want to find the slope of the line. Slope of the line is the rise over the run. Well, the run is this h value, the gap, right? The run, this piece right here, the x's, that's our h. And we have big until it gets really, really, really tiny. The change in y's, okay, this part. Okay, so now let's write that. So we have f of a plus h minus f of a all over h. Now we're going to plug it in. 5, 1 plus h squared minus f of a, or f of 1, okay, over 5, 1 squared, okay, all over h, okay, this h as it approaches 0. All right, so a plus h, okay, we're evaluating at 1. 1 plus h, we're evaluating it at 1. 1 and 1. We want to know right here, okay? So here comes the hard part. This piece right here. 1 plus h squared is 1 plus h times 1 plus h. 1 times 1 is 1, 1 times h is h times h is h times 1 is h times h is h squared. 2h. 1 plus 2h plus h squared. Okay, so now we have 5 times what we just did. 1 plus 2h minus h squared minus 1 times 1 is 1, 5. Okay, now there's the slope of the line. The change in y, right? Slope. Change in y over the change in x. y2 minus y1 over x2 minus x1. This is y2. This is the second value of y. This is the first value of y. Okay? When x is equal to 1. That's where the 1s came from. Okay? All over h. Okay, so now we got to distribute. 5 plus 10h minus 5h squared minus 5 over h. 5's cancel, giving us 10h minus 5h squared over h. We can get rid of an h, leaving us 10 minus 5h. Okay, so now when you evaluate at 1, see how the h's are going to go away, leaving us with this. When h is 0, so as we approach nothing, as we approach no gap, we approach this, what is the overall value going to be? 10. Okay? Alright, now, I know that's confusing. The slope of the tangent line is x equals 10. Find a point on the line by finding the intersection of that and the tangent line. The intersection of 1 gives us a 5. We just plugged it in. Okay, alright. Now we need to write the equation of the tangent line. Okay, so we know the slope. That's what we're trying to find. This number right here is the slope of our line. Slope of 10. And we know the intersection point because when we plug the 1 in, so 1 comma 5. So now we can use the equation of a line. Alright. You can see how long these problems take. And there it is. Boom. That instantaneous slope is 10. The equation of the line. Alright. So let's try this one. Minus 4x squared. Okay. So y equals negative 4x squared, just for fun. Negative 4 at x equals negative 1. Okay? So at x equals negative 1, let's just calculate this point real quick. Negative 4, negative 1 squared, negative 4, negative times negative is a positive 1 equals negative 4. This point right there is negative 1 comma negative 4. Okay, so there's our point. Now our goal is to find this slope. Okay, well, we find the slope by using this new concept of f of h as a plus h minus f of a all over h. Okay, so now how do we do the problem? So f of, we're going to have this a plus h. Okay, so we're going to put a plus h in there. So we got negative 4 a plus h minus a plus h squared minus f of a minus f of a which is negative 4a squared all over h. Now the hard part. Do it over here. A plus h squared. That's a plus h, a plus h. So we have a squared plus ah plus plus h squared. Combine those. A squared plus 2ah plus h squared. Okay, so negative 4 a squared plus 2ah plus h squared minus 4a squared all over h. Okay, and that'd be distribute. Negative 4a squared minus 8ah plus negative 4h squared minus 4a squared all over h. You know you did it right when those go away. So now we have negative 8ah minus 4h squared all over h. See how the h's can cancel? That h goes away, that h goes away, that h goes away, leaving us with negative 8a minus 4h. Okay? Now, at negative 1, okay, so now a is our negative 1, where a equals negative 1. And we could have plugged that in here to make it a little bit simpler. Yeah, I should have done that, because that's how our sample problem was, wasn't it? Yeah. Sample problem was when it was equal to 1, so we put the 1 in there. Yeah, I could have put that in sooner. Okay, so negative 8 times negative 1 equals minus 4h, okay, where h is approaching 0, okay, where h is going down to 0. We want to know nothing. We don't want to know on either side. We want to know right at that point. So that goes away. Negative times a negative is a positive. So our slope is 8. 8. So let's just check that before we go on. 8. Perfect. Now we need the equation of the line. And the equation of the line is y minus y equals the slope x minus x. Y minus a minus 4, because we got this point. We plugged it into the original equation to get this. Slope is 8, x minus a minus 1. Y plus 4 equals 8, x minus a minus is plus, 8 times 1 is 8. Subtract 4, subtract 4. Y equals 8x minus plus 4. Plus 4. Okay. Now, you can see how long these problems take, okay? This is 16 minutes, and I've done these before. So, in slope-intercept form, y equals 8x plus 4. Okay, all right. So don't get in a hurry. It's coming downhill. It's going to be d. We kind of sketched that. Okay, take your time. We're not in a hurry. Each one, these are 20-minute problems minimum if you never make a mistake. Have a great week. Have a good end of May. Memorial Day coming up. Have a great 3-day weekend in a week. Bye-bye. These are some problems, aren't they?